Okay, so now we're on question number 9. Question number 9 says, which trig function, or excuse me, which trig equation can be used to find the measure of angle A? So of course our focus is on angle A, and the first thing that I'm going to do is then I'm going to label my triangle. Here's my right angle, so there's my hypotenuse. If this is my angle A here, then this is going to be my opposite side, and what's left over is the adjacent side. Right away, the first thing you should notice, and you should remember we talked about in class, is that they gave you all three sides. The minute they give you all three sides, they're doing you a really big favor, because then that means you can use any of the three trig functions. You can use SO, CA, or TOA. So if I'm at A, if I'm at angle A, well, the sine of A is going to be the opposite over the hypotenuse, right? So it's going to be opposite 36 over my hypotenuse over 39. That would be my sine of A. If I use the cosine function, it would be CA. Cosine says adjacent over hypotenuse, right? So the cosine is going to be the adjacent, which is 15, over the hypotenuse of 39. That's what I have here for the cosine. And the tangent function says opposite over adjacent. So the tangent of the angle is going to be the opposite, which is 36, over the adjacent, which is 15, and that's what I have here. So I have the three trig functions, sine, cosine, and tangent, SO, CA, TOA. And now they're asking us to find the measure of the angle, right? Well, if you remember, in order to use it, find the measure of the angle, you're going to have to use the inverse function, which is why we have all these little negative ones here, right? So the question is, all right, well, which one matches what we have here? Is there any sine function of A here that has 36 over 39 with the inverse function next to it? I got sine functions here, but the numbers don't match, so it can't be C and D, so those are no good. Obviously, there are no cosine functions here, right? So obviously this is not going to be the answer either. And finally, I'm left with the tangent of 36 over 15. And let's take a look here. I have two tangents. Here we go, 36 over 15. And whatever that would be as a decimal, we know that we would hit the what? We would hit the shift inverse function to get the angle. So here it is, 36 over 15, shift inverse function, it's just choice B. And remember, they gave you the three sides, so right away you can use you can set up any of the all three trig functions, which is what we did here. Let's move on to question number 10. Question number 10 was a nice scenario question here, right? It was a nice scenario question. But really, it was pretty, it wasn't even a trig question. It was really a special right triangle question, because they tell me that this is the city zoning department is trying to figure out sight lines called a clear view triangle. Its intersections are shown below. We see here that we have a right angle, right? They tell us, here we go, they tell us that the measure of angle F, excuse me, they tell us the measure of angle F is a right angle. So what did I do there? I drew my right angle. They told me that angle G is 45 degrees, and they tell me that FG is 75 feet. Well, this right angle and this 45-degree angle here should have set a little red flag off in your mind, right? So, because if this is 45 degrees, then what's this side going to be here? Well, this is what? This is a special right triangle. This is also going to be what? 45 degrees. It's an isosceles right triangle, because these two acute angles have to add up to 90 degrees, and 90 plus 90 is 180. So I know that this leg here and this leg here are going to be congruent, right? Well, they told me that this leg here is what? Is 75. And if you looked on your reference sheet, remember that whatever the leg is, x, the hypotenuse is going to be x times the square root of 2. Whatever the leg is, you expect to see the square root of 2 next to it. It's going to be the same leg times the square root of 2. Well, here my leg is 75, so it's going to be, the hypotenuse is going to be 75 times the square root of 2. And very simply, that is choice D right there for us to look at it. So you didn't have to use any of the three trig functions. If you did, well, then you'd still get the same answer, but you'd have to do a little bit more work. But again, guys, this is on your reference sheet. So it's just a matter of looking at your reference sheet, identifying this as a 45, 45, 90 triangle, or an isosceles right triangle. Let's move on to question number 11. Okay, so here we have question number 11. They show us a picture of the Eiffel Tower. They tell us that the distance from here to here is 223 meters. They give us this angle here of 53 degrees. And they want to know what is the approximate height of the Eiffel Tower. So I hope you can see here that we have what? We have a right triangle, right? So what do I do first? If you guess to label it, you guess correctly. I'm going to label my hypotenuse. There it is. If this is my angle here, well then this is going to be my opposite side, and this is going to be my adjacent side. Obviously, they want us to find the height, which would be the opposite side, so there's the O, and they gave me the adjacent side, which is A. Again, the hypotenuse doesn't come into play here. So they want me to find the opposite, and they gave me the adjacent. In SOHCAHTOA, which of the three trig functions has both O and A? O and A, well, it's going to be TOA. It's going to be the tangent function, right? So what I'm going to do here is I'm going to write the tangent of the angle, tangent of 53 degrees, is equal to the opposite over the adjacent. The opposite, I don't know, is x. The adjacent is 225. So the tangent of 53 degrees is equal to opposite x over adjacent 225. I type in 53 into my calculator, I hit the tangent button, and I get 1.3270. Remember, guys, you want to go to 4 decimal places at all times, okay? Don't stop at 1.3 or 2. You want to go to 4 decimal places. So this is going to be equal to x over 225. Again, we're back to basic algebra. What do I want to get rid of here? We've said it a million times in class, so let's say it a million times in one right now. So we get rid of the what? We get rid of the denominator. How do we get rid of that denominator? We multiply across the equal sign in order to get rid of it, right? So I'm going to have 1.3270 times 225 is equal to x. And look at that. I got the x by itself, right? That's what I wanted to do. That's why I multiplied across the equal sign. So when I did that, these two multiplies is going to be equal to x. When I multiply them together, I get 298.5 is equal to x. And when I look at my choices, which one of these is closest to 298.5? And that would be choice C, 300 meters. Let's take a look at question number 12. Okay, again, question number 12. You might be tempted to look at it as a 30, 60, 90 triangle, but let me ask you a question. Anywhere in this scenario, did they give you any information to indicate that this triangle was a 30, 60, 90 triangle? The answer is no. So you can't assume that. If it is a 30, 60, 90, boys and girls, they will give you some type of information. How do you know this is not a trig question? Well, look inside the triangles. Are there any angles there that they gave you? Any definitive angles? Again, the answer is no. No definitive angles. So what did I do? Right away, I recognized, well, this has to be a proportion question. It has to be a similar triangle question. So what I did here was I took my little triangle and I put it right here. Look, here's A, B, D, and there's 2 at the bottom. A, B, D, and there's 2 at the bottom. And I don't know how big AD is. And by the way, that's what they're asking for. They're asking for, they're asking for the length of AC, right? But I don't know how big AD is. And then what I did was I took this triangle, I picked it up, and I stood it up, right? I took it from right here, and I stood it up on its end right there. So then this would be letter C, D, and A. I hope everybody can see that, right? So that this side here is standing up on the right, right? So now I have my 2 similar triangles. They look the same. They're facing the same side. I know that this is 2. I know that this is 8, right? And they don't tell me what this side here is, and they don't tell me what this side here is either, okay? But I can't make a proportion out of this. So if I say, you know, this side over this side, right? If I say x over 2, well, that's going to be equal to x over 8, right? Because 8 over x over 2, what matches the x? The 8. What matches the 2? The x. So x over 2 is equal to 8 over x. And now all I have to do is just cross multiply. Well, x times x is x squared. 2 times 8 is 16. I'm looking for x, right? I just want just x. I just want to find what x is. So I'm going to take this, the square root of both sides, and x is going to be equal to 4. So this side right here is going to be, 4. Okay? Now, why did I do that? Why did I find that? Because remember, again, what are they asking us for? They're asking us for the length of what? Of AC, which is the what? Which is the hypotenuse here. So in order for me to find the hypotenuse here, I need to have at least 2 sides of the triangle in the situation. And once I have that, well, now it just becomes a simple Pythagorean theorem. A squared plus B squared is equal to C squared, right? So 4 squared plus A squared is going to be equal to C squared. So 4 squared is 16, A squared is 64. That's going to be equal to C squared. It's going to be, add those together. 80 is equal to C squared. Take the square root of both sides. And the square root of 80 is 8.94, and which is choice C. Okay, again, do me a favor, guys. Pause this video, play it again, look at this question again. It's very important.